this bonus section of the DTM chemistry class, and in this bonus section we'll be talking about an alternative way to solve a limiting reagent problem. And on the end of this recording we'll show the more traditional approach that I used in earlier videos. And so let's get started. Let's write the problem up here, the flow chart and the problem. And to save us a little bit of time, I went ahead and wrote the balanced equation out for the problem and set it up a little bit for us here. And so on this approach, what we'll be doing is doing a grams to grams type of problem using both of the reactants, and then using the final answer there to determine the limiting reagent, and also doing some work there to backtrack and see how much is excess of the how much we have of the excess reagent. All right, so let's get started. So we've got 110.5 grams of hexane C6H14, and what we're going to do is we're just going to work grams to grams and then pick the one that produces the least number of grams as our answer, because that's the one, the limiting one that will show up there. So let's do that. So we're going to work a grams to grams type of problem. We'll color code it here a little bit to help us out. Fun, right? And so in any grams to grams type of stoichiometric problem, you will have 3 steps. And so the first step is to go from grams of one of the reactant to moles of the reactant. So grams per 1 mole of the reactant, and I worked that out. It'll be 86 grams of C6H14 per 1 mole. Of course, you do that by multiplying the number of moles of each one of the elements in the compound by its molar mass off the periodic table. So that would be 6 times 12, and then 14 times 1, and then you add those numbers up and you get 86. All right, so now we'll go from moles of the reactant to moles of the product that we're solving for. And in this particular case, we're solving for water. So for every 2 moles of hexane, C6H14, we have 14 moles of H2O. Get that from the balanced equation. And then for every 1 mole of water, we'll have 18 grams. I got that off the periodic table as well. All right. So let's work that out. If we work that out, I believe we get 161.9 grams. 161.9 grams of high quality H2O. Okay, good deal. All right, so we're going to do the same procedure for our oxygen reactant. So here we have slightly less, 110 grams of oxygen. Oxygen, for every 1 mole of oxygen, we'll have 32 grams. Oxygen 16 grams per 1 mole, and we've got 2 moles there. So we'll have 2 times 16 is 32. And then we'll switch over here and do our moles. Here we got grams to moles. Now we'll do moles to moles. So for every 19 moles of oxygen, get that off the balanced equation here, we have again 14 moles of water. And then finally we'll solve out here. For every 1 mole of water, I have 18 grams of water. And when we do that, we get 45.6 grams. Okay, so here we notice that the oxygen will be our limiting reagent. Okay, it runs out first. In the other examples, I gave an analogy of peanut butter and bread. If you're making peanut butter sandwiches and you start off with a full jar of peanut butter, and maybe you only have 4 pieces of bread, well, the bread's going to be the limiting reagent, right? You can only make 2 sandwiches there. If you use 2 pieces of bread per sandwich, you only can make 2 sandwiches because you got 4 pieces of bread. But you'll have lots of peanut butter left over. Well, in this case, we're going to have lots of the hexane left over because the oxygen runs out first. All right, so now we're going to do a slightly different way of figuring out how much of this excess reagent is left. We are going to subtract out the grams of water and kind of make an imaginary number there. And when you subtract 45.6 from 161.9, you get 116.3 grams of water. All right. So you can use that as your starting place to go back to grams of hexane, and that will be the excess left. Okay, so let's do that. So we got 116.3 grams of high quality H2O here. Do another grams to grams type of problem at 3 steps. So here 18 grams of water per 1 mole of water. And then for every 14 moles of water, we have 2 moles of our excess reagent, or hexane. Get that from here, here, and here, right? All right. And so for every 1 mole of hexane, C6H14, we have 86 grams. All right. So when we do that, it'd be 116.3 times 2 times 86, all that in parentheses, divided by 18 times 14, and we get 79.4 grams left of water. I'm sorry, of our excess reagent, which is hexane. All right, very good. So that way might be a little bit easier to do than the traditional way that I will link at the bottom of this video. I'll go ahead and do the traditional way. And I think the traditional way is a little bit easier to think of and see the concepts, but this is maybe a little bit quicker to do the math out. And you don't have to subtract out how much was used from the original in the end, which we'll see in the next slides here. So anyway, I hope you enjoy this. These are probably the granddaddy of them all type of stoichiometry problems, the ones that cause students the most problems, and problems that cause problems. But so I think it's helpful to have students know maybe some different techniques to use to solve them. So thanks for your attention. Hope you enjoyed it. Peace. So, okay, so now we are going to do one of the granddaddy of them all type of problems, limiting reagent problems. And the flow chart remains the same. And we are going to use one technique to do that. You can do these problems a couple of different ways. We'll do my favorite, and then maybe in another set of slides, we may show you another technique to do the same type of problem. Both of them require about the same amount of work. And so you are given 2 reactants, let's say peanut butter and bread, all right, as our example. So let's say that we want to make sandwiches, and we are given 4 pieces of bread and a jar of peanut butter. Well, it doesn't take a genius to figure out that if you use 2 slices, 2 slices for each sandwich, you can only, if you have 4 slices of bread, you can only make 2 sandwiches, 1 and 2, right? And then you'll have a whole bunch of peanut butter left. Well, that's kind of how it is in chemical reactions. Sometimes when you have 2 reactants, one of the reactants runs out first, and we call that the limiting reagent. And then the other one, the limiting reagent, the bread, determines how much sandwiches you can make, or how many sandwiches you can make. So the limiting reagent determines how much product that can be made. And we figured this out by doing the problem in 2 different steps. We figure out the limiting reagent, and then from there we can figure out how much product that we can produce. And then in a separate step, we can figure out how much of the peanut butter is left, or the excess reagent is left. So let's do an example problem here. So we are given, I went ahead and balanced the equation. So we're given here 110.5 grams of hexane, that's this guy right here, and we're given 110 grams of oxygen. So pause the video and write down the problem, and then we'll work it together. Okay, hopefully you've done that. So let's do the problem. We'll start off with 110 it says here 110.5 grams of C6H14. Okay, and so we're going to go change that to moles of our product that we're asked to solve for, which is water. Okay, so we're going to solve for water here, 8 grams of water. But we're going to turn it into moles first, and then we're going to compare the moles of water that can be produced from the hexane and the moles of water that can be produced from the oxygen. And so we'll work these side by side. So we're given 110.0 grams of oxygen, and we are going to turn that into moles of water. So we have grams per 1 mole of hexane, and I looked that up already, is 86 grams per 1 mole of hexane. And oxygen, we have for every 1 mole of oxygen, we have 32 grams. So this is C6H14 here. Okay. And then finally, let's do the moles to moles. So C6H14, there's 2 moles of C6H14 per every 14 moles of water. And so oxygen, we have a whole bunch of oxygens there, moles. We have 19 moles of oxygen per every 14 moles of water. Okay, so now we're going to work these just like any other stoichiometric problem that you go from grams to moles. We'll multiply 110.5 times 14, all right, and divide that by 86 times 2. And here we get 8.99 moles of water. And here on the bottom it's 110 times 14 all over 32 times 19. We can already tell that that's going to be a smaller amount. And there we get 2.53 moles. Okay, so now the one that produces the fewest number of moles of oxygen is going to run out first, and it's going to be the limiting reagent. So here our oxygen is our limiting reagent. So that's going to determine how much water can be produced. And so we'll just go ahead and figure that out here. So for every 1 mole of water, you have 18 grams. So our final answer here is 45.6 grams. So in this particular case, our oxygen is our bread. It's going to run out first, and then we're going to have some hexane left over at the end of the reaction. So how you figure out how much of the excess remains is you start off with where the reaction ended at 2.53 moles of H2O. And to give us ourselves a little bit more room, let's work that on the next slide. Okay, so we have 2.53 moles of H2O at the end of the reaction. And so the question is, how many grams of the hexane were used? That's the excess reaction, or the excess reagent. So here we go from moles of water to moles of hexane. And if we look on the balance equation, we had 2 moles of hexane per every 14 moles of water. And then for every 1 mole of hexane, we had 86 grams of the same. 6 times 12 gives you a number, then plus 14, right? Will give you 86 grams. And then when we work that out, 2.53 times 2 times 86 divided by 14, I get 31.1 grams of hexane used. Okay, and so to get what's left, you would take the 110.5, that's the original amount that we started with, minus 31.1 grams used, and we get 79.4 grams of C6H14 that is left. A lot of steps there, and it takes lots of practice to do these. There's several practice problems like this in your set with solutions for you. So work those out and see how you come. So this concludes Unit 8, stoichiometry. In Unit 9, we will be talking about gas laws, and those are really, really fun to do as well. And now you have lots of skills on making chemical calculations to help you with the concepts in the gas law chapter. So looking forward to seeing you then. We'll be doing more calculations, learning more chemical concepts and the relationships between all these wonderful phenomena such as chemical reactions and gases and all things chemistry. So looking forward to seeing you then. Peace.